welcome to my YouTube channel. In this video, I will be going through and reviewing my final year project. I worked on it between July and October or November of 2018. Its purpose was to show how IoT or Internet of Things can be implemented to control and monitor our water reservoir. And for this project, I modeled it in such a way that it would be useful within my community. Now, going into the project, I split it into 3 sections before heading into it. So I started with the easiest part first, which was the database. And for this, I used MySQL running on a WAMP server. And the database structure is quite simple. I only had 2 tables. The first table was keeps details for employees. Describe that. Let's have a description of that so that we can. So it just keeps details for the employees. And here you will see my first mistake, where the access code is just plain to see. At the time, I wasn't very keen in encrypting passwords. So if we can see. Oops. We have one user, and as you can see, his access code is just wide open. But other than that, these other details were collected in a relatively complete way. The second table is where I kept the details for the reservoir. So here each piece of data has an ID. The water level was recorded. This is the height of the tank, not the height of the water in the tank. We have the time that it was checked, the date that it was checked, the status, whether the tank is filling up, whether it is stagnant, or whether it is the water is being distributed to consumers, the volume of water that is in the tank, the flow rate per second, the liters that have been pumped out, and the payments that are due. That is judging from all of this data that has been collected up here. So yeah, that was the structure of the database. It was very simple. I wanted it to be as simple as possible so that I could work on the next stage, which is the interface. And for the interface, I used Visual Studio 2010. And this was a splash screen, a very simple screen. This is a login page, very simple login page. This was my main menu, also very simple as well. On this, I had a form where I was collecting data for the employee data. Again, I wasn't very big on specific details. I was just having a simple form, and this was the main business end of this whole system. From here, you can be able to control the reservoir, and these gauges, they were custom. I had to download them. Everything that is here will be accessible via my GitHub account. I'll put a link in the description. So I had the gauges. So this gauge indicates the volume of the water in the reservoir in liters. Here I have, so this here, the water height corresponds to the water level. So that is what is, here it is in meters. So from here I get the volume in meters, and then I get the volume in liters. Over to this gauge, it just shows the flow rate per second of the water, and here on this drop down is where all the ports will be listed. Now this is important because it is through this that we'll be able to connect to the hardware that is collecting the data. So after you've selected a port from this drop down, you'll just click connect and you will see the status of that connection here. So now moving down, there are some more functionalities you can see in this on this data collection form. I have a data table, so what it basically does is display the data that is already in the database. I put it there because there was a lot of free space, I guess. This links back to the menu. This closes the interface altogether. And in this small section over here, you'll be able now to actively control the pumps. So this is the inlet pump. So you just click on the radio button, click on, and the status will change from off to on, and it will activate the physical pump. This is the outlet. If it is off, you can turn it, you can switch it on or off. And here for both pumps, it only switches both pumps on. So this is a restriction that I added to the functionality, that you cannot have both pumps functioning at the same time. So this is just a kill switch for both pumps in case you feel like something has gone wrong, or in the event that you try to switch on one and it completely refuses to respond, you can just use this. This is more of a kill switch for both pumps. And finally, you have the data processing center, and I'm really not confident in the way that I did this, because like the button that is supposed to do the processing is empty. It doesn't have any functionality to it. I have data for the table, I can see that. And I think the problem that I had with here was the inability to filter out data using dates provided, using the dates that I had provided. So I think that, and plus I ran out of time because I was focusing a lot on making the Arduino segment work. So for this data collection, the bulk of it was actually working through here. So this is the back end. Let us click no. I don't need that. So this is the back end of the data collection interface. So this is where I was connecting now to the Arduino that is collecting data, and that is now the third segment of this of the project. So as you can see here, I had let's go back to the front end. So here I had a serial port, and that serial port is now what I'm defining here. I'm selecting the baud rate, that is how it's going to be communicating with the Arduino, data bits that I'll be having, parity, everything that I'll be needing to connect to my Arduino in order to receive the data that the Arduino is going to be getting in. And I believe I have a photograph of the whole setup. This is the documentation for that project. It will also be in the GitHub link that I'll put below. All of this is just encompassed as one project on my GitHub. So let me look for. So here I have it in a bit more detailed, though it wasn't. I didn't. As per the level that I am right now, I think I could have done a better job with this documentation, but we'll just run with it as it is. So this is the login. This is the splash screen. We have the login, the main menu, So this is yeah, the data collection of the data entry for employees, processing. This is what I was looking for. So now here you can see several things. The first is you can see the Arduino Mega that I was using. So this is a brains for the monitoring and control. This is just the driver for my stepper motor. My stepper motor is this here, is this one here, and then I also had this this tiny servo motor. Now the purpose of these two motors was quite simple. It was supposed to show the switching on and off of the motors. That is the motor that is pumping water into the reservoir, and the pump that is pumping water out of the reservoir and distributing it to the consumers. So that was their purpose, and with this review I have removed both of them. Reason being, I've found I have simpler motors to use now, which will not require the extra programming that these two required in order to function. And this is now what will be helping us to check the level of the water in the reservoir. And so it will be checking the level of the water in the reservoir, sending it back here, and then from here it will be sent straight to the interface. And I think I have a photo of them working in unison, so you can see here these gauges are working. And here we have the servo motor, and the stepper motor is somewhere here. And here I'm using a 30-centimeter ruler to mimic or to stand in for the 3-meter tank that I am working with. So I'll just be inverting the readings to read. I'll just be inverting the readings so that I can get the results that I want. So that when it's empty, instead of reading 30, instead of us reading 30, if the tank is empty, instead of us reading 3 meters, we're going to be reading 0. So there is some inversion that I did in the code. And I think that's what you're going to go to next, since we've already seen the interface. So let's switch on to the Arduino code. And here I have the two versions. This is the first version, which had the stepper and the servo motor. And as you can see, it was quite chunky. I had to write code on how to turn each motor when it is switched on or off. I also had to account for that. So with the new version of the code, I have removed the stepper and the stepper motor and the servo motor. So I just have two simple motors in and out. So I've defined their pins here, and as you can see, the code is simpler to go through. So this is what I'll be working with now. I'll just connect my Arduino. Let me connect and run it and just upload. So as it uploads, I think now I'm going to just run the project so that we can see the interface in action. And then after I run the project, when we've seen the interface in action, I can just take a snapshot of the whole setup working in unison. So I felt this is important to look at, because this is now how I am doing the inversion of the readings. This is how I am going to be able to get 0 when the tank is empty, and 3 when the tank is full, because the sensor, the ultrasonic module is going to be up here. is going to be up here. So when the tank is empty, it would, because it is at maximum, it would be reading 3. So with this inversion here, it will be reading 0, because if you key in 30 here, 30 30 is 0. You divide that by 10, it still remains 0. So you'll have the tank reading as empty. So this is a very simple formula that I used in order to get the results as they'll be appearing. So let's go on and run the project and see how the interface works. So giving it a moment, and here it is. I think it looks pretty nice. Enter. I'm going to add in a username. Let's use admin. I think that is the correct. Yeah. So login successful. Data interface. Edit. Add user. So this is where you'd add a new user. So let's put in surname like Robinson. Other names could be Terry, Guinness. Telephone number, let me just guess out something. Residence could be Gotham. Passport or ID. Access level. I'm not really sure what difference it would make for those. The username can be Rob. The access code can be Terry. So first of all, verify that it's okay. New record has been added, and so we have, can we go to the database and confirm? No. Yeah, so it works. We can just go back, reports viewing. Yeah, I didn't work on that module. Let's go to the data interface. Now this is where the magic happens. And first we're going to select the port that we're going to use. So as you can see, there are a few here that you can choose from. And the best way to know which is to use the device manager. With the device manager open, we'll go down to ports. Let me open my magnifier so that we can have a better look. Okay, so these are the ports, and Arduino Mega is connected at the port called COM8. So that is where that is the one that we're going to select. There are 2 of them. I'll just say mini mini mo and connect. So as you can see, it is giving us some values. It is reading some values. So it is indicating that it is almost empty, that the tank is almost empty. So I'll tell the inlet pump to switch on. And that, I don't know if you can hear the rumbling, but that is the inlet pump buzzing to life. let me switch that off now. You cannot switch on both pumps, as I said before. That's the error message right there. So let me exit from this, close it, exit. So with that small demo, I think we can let's have a look at the data that we've probably gotten from right now. So select all from water level. Yeah, so all of this data is from today, the water volume, flow rate per second. And I'm not really sure whether this is accurate. I really doubt whether I worked on this section as effectively as I should have. But as you can see here, the status of the tank was stagnant, and it changed to filling once we switched on the pump, the inlet pump. So yeah, that's good. I think from here now we can just move on to displaying how the whole system works together, and I'll have now to zoom out of my screen and start recording with my phone. So we have the Arduino set up, and I'll start with this. This is Arduino Mega. As you can see here, this blinking light here, let me zoom in so that you can see it. This light here blinking, as you can see, it is labeled TX. That is transmission. It means that it is currently transmitting some data. Over here we have just a simple DC motor. This is going to be simulating our inlet pump, the pump that is going to be filling our reservoir. Here we have the ultrasonic sensor. This is what we are going to be using to determine the height of the water in our reservoir. This is also another DC motor. It is going to be simulating our outlet motor. This is the pump that is going to simulate the pump that is now distributing water to the rest to our consumers. And this strip of paper here is going to simulate our reservoir. It is marked out. I can't get it to focus. Okay, it's going to be simulating our reservoir. It has some levels labeled. So at this point here, we are supposed to see that the reservoir is empty all the way up to where it's going to be completely filled. So from here we are going to just jump into operating it directly. So we are looking at the interface to our left and Arduino to our right over here. So I'm just going to go ahead and connect to the Arduino COM port 8 as we had seen before. Click connect, and we can immediately see that it is bringing in some values. It's bringing in some negative values because it is behind the 30 centimeter mark. So bring it a little to the front, and yeah, so we can test out controlling the pumps. I'm going to start with our inlet pump. So immediately I select the inlet pump here and click on. I expect that motor to start running. So 3, 2, 1. So as you can see, it is responding, and so when that is on, it means that the level of the water is beginning to rise slowly, and we can see the same in effect on our gauges. Now I can switch it off by clicking the off button here, and it is off. I can select the outlet pump, tell it to switch on, start distributing the water. As you can see, it has started. And if the water is distributing, then we expect the level to start going down, as depicted on our gauges. And so now I can switch this off. So what if we try to switch both on? So we get an error there that we cannot activate both pumps. But in an event where we will be having both on simultaneously, we will have to switch them off. Or in a situation where we are not sure if it has switched off, we can always use that as a kill button. Yeah, so we can have that as our kill switch if we ever want to switch both of them off, or just make sure that they are both off. So we have that on. If I come here to both pumps and click on off, it will switch off. So in case the off command for the inlet or the outlet pump alone does not seem to bring in the results that are desired, you can switch them both off at the same time. And so that's just it on how it functions. You can just try to bring it all the way up. Let's first of all switch on the inlet pump and just you can see that the gauge is rising as we increase. Now it does have an issue with sudden changes because it only responds at a rate of I set it to function in the code. It functions at a rate of the pulse rate is at about 1 second. So if I change the level too fast, you will see the very sharp differences, almost like now that spike. It's probably because it happened within the span of more than a second. So let me switch off that pump. Oh, both pumps off. Okay. So now we can just go into a database and see the data that we have collected so far. Jumping right back, we are now looking at the data that we saved while running the program, the project. I mean, so let me just quickly describe this table. So we want to arrange to get all of the data, but we want to get it as per the most recent. So select from this. So we want to order it by so it has listed everything. So this is the data that we got most recently. And as I said, the negatives are because of sudden changes. in the distance between the ultrasonic sensor and the cardboard that we were using. So anything that happens faster than the 1 second period causes those differences, causes a very big difference in the readings. So that is a mistake on my part. I didn't program the I didn't program it to take to get a mean of at least 3 readings. So that way we would be having at least a more accurate reading each time that it is sending a reading to the system. So so from here I am just going to jump right back into the code and mention a few things because I just want to wrap this up now. With this project, there are a few things that I would have done differently. So I have a small list here of future improvements. So the first is the code can be improved for more accurate readings. I've already talked about that. A good way of ensuring that is getting a mean of at least 3 readings. You get 3 readings, get a mean, and then that mean is what you transmit as your reading to the program. A change in the module. Of course, this the module that I showed you, the ultrasonic module, it wouldn't survive in that kind of a setup. As we said, this is just to show how IoT can be used to monitor and control a water reservoir. So I wouldn't use this ultrasonic sensor. It is a it is a HC. It's a HC something. Where is it? It's not written on it, but I'll put it in the description. But I wouldn't use it to in a humid environment because it would rust, and yeah, it would definitely rust. It wouldn't last more than a few days. So I would use something different. There are ultrasonic sensors which are built for humid conditions. So that is what I would definitely use. As another improvement that I'd make working on it is having a different programming language. Using Visual Studio was really interesting, but the problem is that once, like right now, the most recent is Visual Studio 2022. I'm not really sure whether this project would port into Visual Studio 2022. I'll have to try it out. But I had installed it before reinstalling Visual Studio 2010, and I had quite a number of problems trying to set this up. So something web-based would be better. Using a framework like Django or Flask, or you can use Java and use a JavaScript framework, whichever is going to work out just fine. And if you choose to go this route, you'll need to use a GSM or a Wi-Fi module. They are quite easy to integrate using the current code that is there. The only thing that you'll have to play around with is you'll write a bit more code for the Wi-Fi or GSM module because it has to send out data, it has to receive commands as well. So making sure that that connection is always there is also going to be a small challenge that you'll have to overcome. But it is very good because it will definitely turn this project from being something that you have to man all the time to something that you can monitor and control remotely. So final improvement would be working on the reporting modules since they weren't working to begin with. With this, I think what happened is By the time I was getting the Arduino and Visual Studio to cooperate with one another, I'd already spent so much time there that there was literally no time to work on the reporting modules. The reporting module that is supposed to be filtering out data was the only thing that I could work on, and I didn't do it to completion by the time I was presenting the project. But moving forward, that is a module that I would be very much interested in working with. I've already created a separate branch so that I don't change the original code as much. I've already created a separate branch on which I'm going to be working on. I'd probably be working on it, or use this approach to do the project afresh. Probably I'll maintain the gauges because they're very nice to look at. But yeah, these are just the improvements that I would make. And I think a question that many people will be having is this really applicable? And to that, I'll say yes, it is very much applicable. Because this technology, number one, is extremely cheap. You'll just need one module. It may not be applicable in like a large scale set. Yes, it would be applicable in a large scale setup, but it will need a bit more intricacies. It will need a bit more attention to how it is developed as a whole. But if you would want to implement this in your own private home or something of the sort, and monitor maybe how you're watering your plants, or how on the water level in your personal reservoirs, it is very applicable. Just to make sure that you use a proper ultrasonic sensor that is made for humid conditions, not the one that I had displayed initially. And with that, that is a complete review of the project. I didn't go in depth into the code because of the time it would take, but thank you for staying tuned. If you have any other project that you'd like us to go through, you can drop it in the comments below, and I will see you next time.